Good afternoon, guys. I'm making this video to help you with the worksheet that you were given yesterday in class for odd students and today for even students. I'm literally just going to jump right into it. I'm sorry it took me so long to make this video. I just forgot. Okay, before I even get into the answers and how to do these problems, you first have to be familiar with the types of reactions. Okay, so we're going to start off very simple. We have our synthesis reactions, the most basic ones. Very, very simple, okay? These synthesis reactions, you are only going to see them with two elements. That is the only type of synthesis reaction you're going to see. So if I have two elements as reactants, you already know that that's going to be synthesis, okay? And how do I get the products? Well, product, not products, sorry. One product. How do I get the product? Well, aluminum is a metal, and it carries a +3 charge. Bromine is a non-metal. It carries a -1 charge. When you cross these charges, you get AlBr3. Okay, and that will be an example of a synthesis reaction. Now, of course, you have to put your states of matter, you have to balance the reaction, etc. But just for, a recap, I'm just going over the types, and then we'll do all that extra details in the questions. Okay, so that's synthesis. Okay, again, I have two reactants, and one product. Again, the reactants are elements. Okay, decomposition is the opposite. I will have one reactant and two products. Okay, this is a binary decomposition. Why is it a binary decomposition? Because this is a binary compound. Okay, this compound right here is a binary compound. What is a binary compound, you might ask? You should know this. Okay, binary compound. I'll write it over here so you know. Compound with two elements. Okay, this is a compound with two elements. Okay, this binary word that I keep hearing students say when I ask them what kind of reaction this is, the binary word only applies to decomposition. Okay, you can't have a binary synthesis. That makes no sense at all. Binary only refers to decomposition. Okay, and same with the next three that I'm going to tell you, only refers to decomposition. It's a type of decomposition. Okay, so that's a binary decomposition, the most simple one. Okay, another type of decomposition you might get, a metal hydroxide. Metal hydroxides break up into a metal oxide and water. Again, this is a metal hydroxide decomposition. Another type, potassium chlorate, a metal chlorate, will break down into a metal chloride and oxygen. This is a metal chlorate. Okay, a metal carbonate is a metal with carbonate. Okay, so a metal with carbonate, a metal with chlorate, a metal with hydroxide. Okay, that's where I'm getting these words from. Okay, these metal carbonates, they like to break down into metal oxides and carbon dioxide. Again, 4 types of decomposition. All of these fall under decomposition. Do not get it twisted. Okay, next, combustion. Okay, and very big blue words. Must have O2 as a reactant in order to be a, sorry, I gave up with the capital, combustion reaction. Easy. Must have O2 as a reactant in order to be a what did I just write? Hold on. Combustion reaction. Okay, again, if I have A plus B yields C and D. I'm making this up. These are on the left, my reactants, and these on the right are my products. Okay, please don't mix that up. So O2 must be a reactant in order for it to be considered combustion. Okay, let's go through some examples. Literally anything reacting with oxygen is combustion. So if I were to just give you, aluminum, plain aluminum, reacting with oxygen. Oh my god, I can't write. Combustion. Potassium reacting with oxygen. Combustion. Magnesium reacting with oxygen. Combustion. Okay, so all of these reactions are combustion reactions. Okay, because why? I have oxygen as a reactant. Another type of combustion is whenever I have a hydrocarbon, which is a compound with hydrogen and carbon. Okay, when I have a hydrocarbon reacted with oxygen. However, the products are different. You don't combine these together. The products are always CO2 and H2O. Okay, this is another type of combustion. Again, oxygen is reactant. This cannot be combustion. This is not a reactant. Okay, don't get confused. Next, single replacement reactions. I'm going to say SSR for short. Sorry, SRR, single replacement reaction. Okay, remember there are 3 types of single replacement reactions. Metal replaces metal. I'll put capital M. Metal replaces metal. Sorry. Hydrogen in H2O or water, right? Or an acid. Okay. Bye, have fun. Okay. And a non-metal replaces a non-metal. 3 types. Okay? What does a metal replacing a metal look like? The single guy that I have. I keep using aluminum for some reason. Calcium. The single guy that I have is going to try to replace another metal in a compound. What did I do? NO3? Yeah, that's fine. Okay? Again, can calcium replace potassium? Can they switch places? I don't know. What do you have to check? The activity series. Check the activity series. It's in the PowerPoint. Okay, check to see if calcium can replace potassium. If it can, great. Switch them and cross the charges. If it cannot, no reaction. Okay, metal replaces H in water or an acid. So I'll use the same one for this. This is simple. Metal replaces H in water. Metal replaces H. I'll keep it simple. H in an acid. Okay, this is going to become, for the first one, KOH plus H2. The second one is going to become H2 is by himself. Actually, I kind of want to put this in front so you guys don't get confused. Hold your thought. Hold everything. Let me just change them. Okay, good. Perfect. Okay, so, and then this is going to become KNO3. You're like, what the hell is she doing? Watch. Okay, when a metal replaces hydrogen in water, right? When there's a replacement going on with these two things, you're always going to get a metal hydroxide and hydrogen gas. If a metal is replacing hydrogen in an acid, you just switch their places. You're still going to get hydrogen gas, and now K is going to be bonded to NO3. Okay, remember what I told you about water? Water can be written as HOH. The K is replacing the H. The H is plus. The OH is minus. If it's replacing this H is no longer there. K is now going to be bonding to OH, and that is why I have KOH in my formula. Sorry, in my reaction. Okay? Non-metal replacing a non-metal, pretty simple. Okay? Non-metal wants to replace a non-metal. According to my activity series, it can. They switch places. Now Br is by himself, but there's a 2 because he's diatomic, and Na is with F. Okay, that's single replacement. Excuse me. Last but not least, double replacement. Make sure it's still recording. Okay, double replacement. I have two ionic compounds. Who do I want to use? Sorry, hold on. Who do I want to use? No, I don't want to use ammonium, actually. Who do I want to use? Let's use sodium, I guess. Okay, perfect. Okay, what happens in a double replacement reaction? Simple. My cations stay in place. My anions switch places. SO4, okay, SO4 is now with Cu. According to this, when I uncross it, Cu has a 2+ charge. SO4 has a 2- charge. Together they make CuSO4. Plus, OH is now with Na. Na is plus, OH is minus, making it NaOH. Okay, so that is the 5 different types of reactions kind of summed up and summarized as best I could. Okay, now going back to this worksheet. First of all, I want to point out that heat should not be confusing to you. Ignore it. Pretend it doesn't exist. Pretend it's not there. If you want to just scratch it out completely and just have that, that's fine. Okay, the heat it doesn't make a difference. Okay, all of this certain type of reaction. I'm not going to tell you what kind of reaction this is yet, but all of this type of reaction requires heat. That's why it's mentioned. It's just required to do this type of reaction. Okay, but do you see, as a hint, how many reactants do I have? How many things are on this side of the arrow? Keep that in mind. There's only one type of reaction that contains that. Okay, let me, I forgot to add it. Let me add it. Oh, surprise, there it is, the answer. Okay, good. Perfect. So, going up here. I'm going to do number 3 with you. And number 4. Okay, number 3. I have 2 compounds here. 2 full ionic compounds. Do synthesis reactions have 2 full ionic compounds? No. Do decomposition reactions have 2 full ionic compounds as reactants? No, they only have 1 reactant. It can't be that. Do combustion reactions have 2 full ionic compounds as reactants? No. Do single replacements have 2 full ionic compounds? No, they have 1 element in 1 compound. So last but not least, decomposition is the only one that has 2 full ionic compounds as reactants, therefore making number 3 a double replacement reaction. So in here, number 3, I'll put DRR for double replacement. Okay, I know that the cations stay the same. I'm switching the anions. They swap places. ClO4 is now with Na. Na has a plus charge according to the periodic table. ClO4 is perchlorate, a polyatomic with a -1 charge. When I cross them, I get NaClO4. Okay? Excuse me. Plus my second product. Okay? Now I have OH being bonded with H. Okay, again, they're switching places. These 2 guys are literally switching places. So OH is now bonded with H. Well, what's H? Plus, what's OH? Minus, what is that? HOH. But do we write water like that? No. H2O. Okay? Good. I'm erasing this, just so it's not too messy. Okay, next thing I need to do is put my states of matter. My odd kids did not get a reference sheet for states of matter. My even kids did. So odd kids, use the table on the periodic table. Okay? If you use the reference sheet on the periodic table, and the PowerPoint. If you use the reference sheet in the PowerPoint, you would see that this compound is aqueous. And H2O is obviously a liquid. Okay? Next, I have to balance everything. So let's count everything up. Hello, pen. NaOH, Cl. That's it. NaOH, Cl. Na is 1, O 1. Sorry. O is 5, H is 2, Cl 1. Na 1, O is 5, H is 2, Cl 1. So this reaction is actually balanced. That's it. You're done. Don't put ones in front. Don't do anything else. You're finished. Okay? All work needs to be shown for the balancing part, by the way. All work needs to be shown. Thank you. Okay? Next. I guess we can do this one together. Yeah, we're going to do this one together. Like I said, ignore this. Okay, how many reactants do I have here? Just one. Just one reactant. What's the only type of reaction that has one reactant? Decomposition. Okay, and what is that compound? ZnCO3. Zn is a what? Zn is a what? Metal. CO3 is what? A polyatomic called carbonate. This is a metal carbonate. Okay, do I have any metal carbonates over here in my decomposition section? Yes. How do metal carbonates decompose? They form a metal oxide and CO2. Okay, going back up here. Metal oxide and CO2. Easy. Erase all this. Hey, who's my metal? Zinc oxide. O. 2 minus. Do I know the charge is zinc? It's a transition metal, but it has a specific charge. Remember, there are 3 elements on the, 3 transition metals on the periodic table. Zinc, cadmium, silver, that don't use Roman numerals, and you have to memorize their charge. Okay, zinc is one of them. It's 2+. Okay, keep that in mind. When I cross the charges of these 2 elements, I get Z and O. There's product number 1. Okay? Product number 2 was CO2. Simple. Okay? Z and O, all metal oxides are solids. That's listed on the reference sheet. Again, even kids have it. I will get it tomorrow. Sorry about that. Carbon dioxide is a gas. Okay? Let's balance. Okay? Splitting this up, I have ZnCO, ZnCO. I have 1 Zn, 1 C3O, 1, 1, 3. Huh, this is balanced too. You're lucky. Okay, again, this is decomposition. So for number 4, I put D for decomposition. Okay? What the hell? Where's the one with balancing? Let's do this one. Maybe this one balances. Okay. Actually, you guys can do that one. That one's easy. Actually, I guess I'll do it with you. Fine. You convince me. Okay. Again, 2 compounds. 2 full ionic compounds is double replacement. So number 7 is a double replacement reaction. Okay? Perfect. Meaning, my cations, they stay where they are. My anions swap places. CO3 is now with calcium. Calcium is 2+. CO3 is 2-. That gives me CaCO3. Okay? Next. Chlorine is now with potassium. Potassium is plus, Cl is minus, that is KCl. Okay? Good. My products are written. Next, I have to balance it and write my states of matter. Okay? You should have your reference sheet in front of you for this. This is aqueous. And I believe that CaCO3 is a solid, but let me check. Is calcium carbonate aqueous or solid? Solid. I'm right. I know everything. Okay, great. So, there's my states of matter. Sorry, I didn't have the chart in front of me. If I did, then I wouldn't have looked it up, but I didn't have the chart. Next, balance. Okay? Is this already balanced? Barely. Okay, you guys should all know how to balance by now. You have an ed puzzle to balance on due Sunday, so that could help you. Just to keep it simple, CACL, KCO, CACL, KCO. Sorry, I know this video is like getting really long, that's why I'm like speeding it up. Okay, so everything's balanced except for these guys. Okay, how can I fix it? I gotta multiply this by 1. By 2. Put a 2 in front. How many K's do I have now? 2. How many CLs do I have now? 2. Is everything balanced? Yes. Perfect. I'm done. Okay, so that's basically what you need to do for the worksheet. I think hopefully this was helpful for you. If you have any questions, you know where to ask, you know where to find me. And I think that's it. Okay, with the synthesis ones, a lot of students were getting confused with that one for some reason. Synthesis, like number 1 is synthesis. Mg is a metal. Iodine is a nonmetal. Therefore, it's ionic. Therefore, I'm crossing charges. Mg is 2 plus, I is minus. My product is MgI2. MgI2, I believe, is aqueous. I believe it's aqueous. And it's already balanced. So I put S for synthesis. Okay, that's it. Any questions? Let me know. Hopefully this was helpful for you. Okay? Have a good night. Bye.